In the last video, we talked about similar figures just in general. In this video, we're taking it one step further and focusing only on similar triangles. But since we're focusing only on similar triangles, we're introducing a few new rules that talk about triangle similarity. The first one is called side-side-side similarity. So if the corresponding sides of two triangles are proportional, then the triangles are similar. So before we had side-side-side triangle congruence. That was if the corresponding sides were congruent, then the triangles were congruent. This time it's a little bit different. If the corresponding sides make proportions, then the triangles have to be similar. Okay, so don't get those two mixed up. The next rule we're introducing is called side-angle-side similarity. Okay, so if one angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So, for instance, if I have angle X is congruent to angle M, so just one pair of angles, and then I also know that ZX is proportional to PM, and XY is proportional to MN. If I have that information, you've got to have both sides that include that angle, both sides that include that angle. If those are proportional and the corresponding angle is proportional, then that's enough information to say that these two triangles are similar. Remember in the previous video we said also that if you know two congruent angles, then the two triangles that you have are similar as well. So just don't get those confused with triangle congruence. In example 27, we want to know which of the following three triangles are similar. Alright, so first off, luckily everything's color-coded, so what we can set up is for side-side-side similarity. We said we had to have corresponding sides are proportional. So what that meant is AC over FD would have to match up with BC over FE. Which would have to match up with AB over ED. So 6 over 4. This is only for the first and second triangle. So first and second triangle. That's my rule. So I want to go ahead and plug in what I know and just see if I can eliminate anything. Alright, so looking at my picture, I have AC was 12. So I have 12 over 8 is supposed to be equal to 9 over 6, which is supposed to be equal to 6 over 4. Well, I just want to turn each of these into a decimal. If I get the same decimal all the way across, then triangle 1 and 2 have to be similar. Alright, so I have 12 over 8. I get 1.5, 9 over 6, 1.5, so far so good, and then 6 over 4, 1.5. So since all of these are equal to each other, 1.5 is equal to 1.5 is equal to 1.5, then I can say for certain triangles ABC is similar to triangle FED. Okay? Now I want to go even farther. I want to see, all right, this triangle A similar to triangle GHJ. So I'm going to try side-side-side similarity again. And the reason why I'm using side-side-side similarity is because I don't have any angles. Okay? So blue goes with blue. So I'm going to say 12 over 4. So AC over GJ is equal to green over green. So BC over JH. And that's supposed to be equal to red over red. So AD over GH. Notice I've got the first triangle on top, the third triangle on bottom. So I'm comparing the first and third triangles here. Alright, so now I'm going to plug in what I know. AC was 12 over 14. That's supposed to be equal to BC, which is 9 over 10. That's supposed to be equal to 6 over 6. Now what I want to do again is to use my calculator, turn each of these into decimals. If the decimals all match up, then yes, 1 and 3 are similar. Okay? All right, so I have, let's see, I want to say 12 over 14 is 0.86, 9 over 10. It's 0.9. Now that's close, but close isn't good enough. It has to be exactly the same. So 1 and 3 are not similar. The last pair I need to check is triangles 2 and 3. Triangles 2 and 3. So I'm going to do some work. Kind of running out of room. I'm just going to do it up here. So blue over blue. So FD over GJ is supposed to be equal to green over green, FE, over JH equals red over red, ED over GH. Now I want to plug in what I know. Again, I'm just going to do that over here on the side, so I've got some scratch work. So FD, that's 8 over 14. That's supposed to be equal to 6 over 10. And that's supposed to be equal to 4 over 6. All right, and again, this was triangles 2 and 3. 2 and 3. All right, so I'm going to use my calculator to work. Each of these fractions have to come out to be the exact same decimal. So 8 over 14, get a nasty decimal, 6 over 10, 0.6. So 0.57 and 0.6 are close, but again, close is not good enough. They have to be exactly the same for this to work. So what that means is triangle 1 and 3 are not similar, triangle 2 and 3 are not similar, but the only two that are similar are triangles 1 and 2. So triangles 1 and 2 are the only pair that are similar. Example 28, we're going to use the given links to prove that triangle RST is is similar to PSQ. So the two triangles are similar. All right, so first let's highlight the two triangles we're talking about. So RST, I'm going to do in green. RST is the big triangle. And then PSQ, it's the little triangle. All right, remember, all we need for triangle similarity is either side-side-side similarity or side-angle-side similarity. Those are the only two rules that we really know in this video to use. Side-side-side, you need all three pairs of sides. So I've got green pair, blank. That's not going to work. Blue pair, blank. It's not going to work. So I can't use side-side-side similarity in this one. So the only thing left is side-angle-side. So I'm going to know side-angle-side. Because you have to have both sides that the angle is attached to. For the blue one, I have side-angle-side. You have to have both pairs that the angle is attached to, which I do, so I can use that. All right, so what I'm going to do is say, hopefully, these two sides, the green side is proportional to the corresponding blue side. So that means SR, let's do this in a different color. So the rule says for side-angle-side similarity, SR over SP has to be equal to ST all over SQ. And angle S is obviously congruent to angle S. So this part's already kind of done for us because these two are the same angle. What we're going to do is plug in what we know. For the green side, SR is 4 plus 12. So 4 plus 12 on top, divided by the corresponding blue side, which is just 4. And that's supposed to be equal to the green side, ST, so 5 plus 15, divided by the corresponding blue side, which is just 5. All right. So now what I want to do is simplify each of these. 4 plus 12 is 16. 16 over 4 equals 5 plus 15 is 20 divided by 5. I want to turn each of these into a decimal. If I I get the same decimal, then obviously this statement is true. The proportions are equal. So 16 divided by 4 is 4 on this side. 20 divided by 5 is 4 on this side. So both of these come out to be 4. So that's true. The angles are obviously true based on the picture. So since I can use side, angle, side similarity, the two triangles have to be similar. All right, in example 29, we have a picture. To measure the width of a river, you use a surveying technique shown in the diagram. We're going to use the lengths measured in feet to find RQ. So let's highlight RQ. I have the picture up here, but just based on the colors, it's kind of hard to see. We're trying to find RQ, which is this length, so the distance across the river. We're told that we know that these two triangles are similar because I have an angle congruent to an angle, and obviously 90 degrees congruent to 90 degrees. So this is the angle-angle similarity method. Angle similarity. So the two triangles are similar. So QPR is similar to triangle TSR. Now I'm going to start off by writing my similarity statement. So I know that angle Q is congruent to angle T. Angle P is congruent to angle S. Angle R is obviously congruent to itself. Also, I know that corresponding sides are proportional. So QP over TS is equal to PR over SR, which is equal to QR over TR. Again, for each of these fractions, I have the first triangle on top. For each of these fractions, I have the second triangle on bottom. Now I'm going to use the picture and plug in what I know using my side links. So I'm trying to find QR. So that's definitely one of the fractions I want to need to use. So QR is right here. That's my missing piece. And I'm going to go and say X equals QR. All right. Now I'm going to, obviously, I need TR, which is right here, is 12. So I have X over 12 is equal to, now we know this side, TS. So TS goes with the first fraction and 9's on bottom. TS matches up with QP, which is at the top of my picture, 63. Well, now I've created a proportion. My variable is already on top, so I'm ready to just start cross multiplying. So 9x equals 12 times 63. That's kind of a big number, so I'm just going to use my calculator to save some time. I could do it by hand, but why when you have the technology? So 12 times 63 is 756. So 9x equals 756. Now what I want to do is divide by 9 on both sides. I have x equals, again, I'm going to use calculator to help out. 756 divided by 9 is 84. Well, we know that x equals QR, so my answer is 84 feet. So this length on our picture is 84 feet. So it's 84 feet across this river. So this is called indirect measurement, and it's actually used a lot in surveying. So surveying is just similar triangles. All right, and that's it for this video. Let me know if you got questions.